Good afternoon. Welcome back to Zoology second year class. SAQs already we finished up to the last lesson. The applied biology questions also completed. Only two are left. That is, I will take afterwards. ECG and the ELISA. Next, we are going to discuss about the VSAQs. Clear? Next, first lesson VSAQs. First, in the digestion VSAQs, the dental formula of adult human being. Here, the dental formula, how we are measuring means, all of you know this one. It is the dental formula, half of the lower jaw, half of the upper jaw by half of upper jaw teeth by half of lower jaw teeth. Half of lower jaw teeth. We count it. How we are counting this one means, see this one here. The what is the incisors, canines, premolars, and molars are there. See here I am writing along with that formula the 2 1 2 3 by 2 1 2 3. Here the 2 is the incisors, the 1 is the canines, the 2 are the premolars, and the 3 are the molars. Here. Like this, the half of the jaw is having the 2 1 2 3 teeth are present. Down also same 2 1 2 3 is present. The total how much? Here the 8 by 8. Here that means the 16 into double means the half of the jaw is a 16. Total jaw is the 32 are there. Here in the adults, the adult human being is having this formula is there. Here 2 1 2 3 by 2 1 2 3. Next see this one. This dental formula denotes arrangement of the teeth of the each half of the both jaws. Here, next see this one 2 by 2. This one is the incisors. The second one is called as a canines 1 by 1. Premolars 2 by 2 and the molars 3 by 3. Like this. This is the dental formula of the human being. Here, next one is the second question. The bile juice. Bile juice containing containing no digestive enzymes, yet important for the digestion. How? Here, next the bile juice doesn't contain the bile digestive glands. Means any total glands, digestive enzymes are absent, but the what it is present inside of that mainly bile pigments and bile salts are present. Here, inside of that no enzymes, but bile salts are present. And bile pigments are present. Bile pigments. Here, the bile salts are mainly helpful for the emulsification of the fats. What is the emulsification? Means macromolecules of the lipids is converted into micromolecules. Bigger lipid molecules are converted into smaller molecules by the bile salts. Which are the bile salts? The mainly sodium, potassium, glycolate, and tarcholate. These salts are the breakdown. For example, this like this, the lipid molecule that is breakdown into smaller molecules. For breakaging purpose, the bile salts is useful. Here, see this one. What it is? What here gave means, see, bile juice does not contain digestive enzymes, but contain the bile salts. These bile salts emulsifying of the fats means breakdown of the fats into the very small miscellaneous means micro molecules. Here, next are also called the emulsified fats. Here, the fat molecules or lipids are converted into what it is. See this one. Lipids converted into lipids or fats in the presence of bile salts. Form it as a emulsified. Lipids are emulsified. Emulsified fats are also called as the emulsified lipids. Here, this is by the bile cell. Next is the what? Next, bile also activates the lipase enzyme. When the emulsification is occurred, then that is releasing the bile activates the lipase. This lipase converts the emulsified fats into the fatty acids and glycerols. Here, the emulsified fats are there now. These emulsified fats are further converted into the, see this one, emulsified fats. The already the bile juice is mainly the activates the lipase enzyme. In the presence of the lipase enzyme, emulsified fats are converted into fatty acids plus glycerol. Here, this is the second question. Means the bile juice contain no digestive enzymes. Why that is important? The question here, it is containing the salt. Salts are useful for the emulsifying of the fat, and also bile juice is the activate the lipase. Second step, lipase enzyme activate. That's why that lipase act on the emulsified fat. Further, they are break down into fatty acids and glycerol. Here, this one is about the bile juice. Here, next question. Two VSQs finish. One is the dental formula. Second one is the why the bile juice is important. Next is what would happen? The HCl is not produced in the inside of the stomach. Here, inside of the stomach, the HCl is not, hydrochloric acid is not produced. What will happen? We are going to discuss here. The HCl is the acidic in nature. Here, what is the pH of this? The pH of this is the mainly the 1.8 acidic in nature. And this is having the mainly, if the HCl is not secreted by the stomach, then what will happen means the pepsinogen is not converted into pepsin. Means pepsinogen is the inactive enzyme actually. Pepsinogen is inactive enzyme that is not converted into pepsin. That mainly the pepsinogen is converted into pepsin by HCl. Pepsin by HCl. If the HCl is not there, what will happen? That is inactive condition only. It is not activated. That is the one reason. Next, the protein digestion and the milk digestion does not begin. Means the pepsinogen is not produced. Means pepsin is not produced. Means the proteins are not digested. Means milk also having the proteins. Milk and the proteins are not digested. The digestion does not begin. Next is the microorganisms that taken along with the food is not killed. Majorly, what is the function of the HCl? Means HCl kills the bacteria. It kills the first function is the inside of the stomach HCl. Along with the food, any microbes are entered in our body. The stomach producing HCl kills that microbes. Second, they activate the pepsinogen and prorenin into the pepsin and renin. Here, next, they are microbes are not the microorganisms that are taken along with the food is not killed. Here, these are the means. What are the reasons? First reason is the mainly the mainly they are not activated enzymes. Inactive enzymes are not activated. Second, the HCl is not produced in the stomach. Microbes are not destroyed. Here, this one is about the HCl. Next one is Next one is the what is chyme. Here, next acidic food. The means the chyme is the acidic semi-digested fluid present in the stomach. Stomach already we discussed stomach producing the HCl that is acidic in nature. The food is mixed with the HCl. What will happen? That also becomes as a acidic in nature. Semi-digested means partially digested food. Here, semi-digested fluid food that is acidic in nature that we call as a chyme. Here, chyme it is a the acidic semi-digested fluid food formed by the stomach. Next, it is formed by the churning movements of the stomach muscle. Stomach is having the muscles now. That muscles are performing the churning movements. In that in that movement, the semi-solid, semi-digested fluid is formed that is acidic in nature. That we call as a chyme. Chyme every time the acidic in nature. Next is the chyle will be there. Chyle is present in the intestine that is as alkali in nature means the intestine is having the pancreatic and the intestinal juice now with that they are the alkali in nature. That's why the that is the chyle is the alkali in nature. Clear? This one is about the chyme. Here, chyme means the acidic semi-digested fluid food is called as a the chyme. Next, the what are the different types of see what are the different types of papillae present on the tongue? On the tongue, which type of papillae are present? We are going to discuss the three types of papillae are present. They are called as a see this one. Simply, I am drawing the diagram. See like this, they are papillae are present. The types of papillae present on the tongue are the fungiform papillae, filiform papillae, circumvallate papillae. First, what it is? First, the circumvallate, fungiform papillae. These are located in the margin and tip of the tongue. Here like this, they are formed as a fungiform. This is formed as a the tip of the tongue. Here, these are located margin of the tip. Oh, sorry, this is the here. These are the circumvallate. This one is called as a the fungiform, and one more is a that we call as a filiform papillae. Here, three types of taste buds. Papillae are also called as a taste buds. How it is means, see this one. This one is the which one last edge, the tip and edges is having the fungiform papillae. Fungiform papillae. Next, the filamentous papillae is present that we call as a filiform papillae. At the total surface located on the upper surface, they are present. That is called as a filiform papillae. Next, these are located at the base. Base surroundly they are arranging. That's why we call as a circumvallate papillae. They are present at the base of the tongue. That we call as a circumvallate papillae. Here, three types of papillae are present on the tongue. First is called as a fungiform papillae. They are located at the margin and tip of the tongue. Margin they are having and tip of the tongue also they are having. Next is the filiform papillae. They are present upper surface of the tongue. And next circumvallate papillae. These are located at the base of the tongue. Here, this is about the types of papillae. Three types of papillae. What are they? Fungiform papillae. Here. And second is the filiform papillae, circumvallate papillae. In the name only there. Fungiform papillae, it is present in the edges and the tip of the tongue. And the filiform papillae at the surface of the tongue. And the circumvallate papillae, base of the tongue. Here. Next. See, this one is also important. Name the hormones. Not only in the digestive system, not only the enzymes are produced, some hormones also produced. They are called as a name the two. What is the question? The name the two. Name the two hormones are secreted by the duodenal mucosa. Duodenum means the intestine. First part is called as the duodenum. The ileocecum duodenum. Ileum. Here, the U-shaped structure is called as a duodenum. The duodenum mucosa. Inside of that, the already I said the intestine is having the three layers. Inner layer is called as mucosa. Duodenal mucosa secreting two hormones. Which one means they are the these hormones duodenal they are secreting the duodenal mucosa secreting the GIP means the gastric inhibitory peptide hormone. Here the gastric juice, the stomach is producing the gastric juice. Now that gastric juice production is inhibited by the particular hormone that is called as a GIP. That is that the gastric inhibitory means stop. Gastric inhibitory peptide and the secretin. Here they are stimulates the pancreas for the pancreas stimulating purpose, secreting hormone. Next, gallbladder, the secreting hormone is there, cholecystokinin. Like this, which hormones are secreted by the duodenal mucosa means the GIP, what it is, the gastric inhibitory hormone peptide, and also next second one is called as a secretin, and third one is called as a cholecystokinin. Three hormones are secreted by the duodenal mucosa. Here, this one is about the next. With this, the first lesson almost the important I explained. Next is the respiratory system. Here, this one is the important one. See this one. Next, it is the belongs to respiratory system. Respiratory system. The first unit, first B, respiratory system in human. Second chapter, the 1B, VSAQs. These are the VSAQs. Here, see this one, the vital capacity. Here, the capacities and volumes we discuss in the SAQs. That only here the capacities and what is the capacity means the lung capacity. Here, vital capacity means the maximum volume of air a person can breathe. The forced expiration. Here, the breathe in means after the expiration, removing out, the immediately how much the air is taken inside of the lungs, that we call as a vital capacity. Maximum volume of air a person can take after the forced expiration. Forced, we are removing the air forcibly. After that, how much air we can take inside of the lungs, maximum how much we are taking, that we call as a vital capacity. Here, next, it includes the expiratory tidal volume and the expiratory tidal volume and the expiratory reserve volume and the inspiratory reserve volume. See this one here, the vital capacity is equal to tidal volume. Here, how much air we can take inside, that we call as a tidal volume, plus in expiratory reserve volume means the forcibly we are expired inside of the lung, how much volume is left, that is called as a expiratory reserve volume. Next, inspiratory reserve volume means we are taking the air in extra, how much we are taking, that we call as a inspiratory reserve volume. That is called as a vital capacity. Vital capacity helps the diagnosis of the lung diseases. For the diagnosis of the lung diseases, underlying lung diseases mainly we can identify by these volumes. Clear? Vital capacity, we can count, we can diagnose the lung diseases. Here, what it is, BC is equal to vital capacity is equal to, simply we write it this equation also. Okay. Next, the tidal volume plus expiratory ERV, expiratory reserve volume, plus the IRV, inspiratory reserve volume. After the forced in expiration, how much volume is present inside of the lungs, and the inspiratory reserve volume means how much extra air we can inspire. That we call as the inspiratory reserve volume. The total we called as a vital capacity, means the maximum how much air we are taken inside of the lungs after the forced expiration is called as a vital capacity. Next one is the what is the effect of the PCO2 by the oxygen transport? Here mainly the carbon dioxide is more automatically, the oxygen taking capacity will be decreased. So here the what is the effect of PCO2 on the oxygen transport? Oxygen transport, what is the effect of the partial pressure of carbon dioxide? PCO2 means partial pressure of carbon dioxide. If the partial pressure of carbon dioxide is more, automatically oxygen transportation is less. That how it is. What is the effect of the PCO2 on the oxygen transport? Here, a rise of the PCO2, partial pressure of carbon dioxide is increasing, decrease the affinity of the hemoglobin for oxygen. Hemoglobin is the oxygen, carbon dioxide pressure is more. They are not efficiently take the oxygen. The more inside of the blood, carbon dioxide more, carbon dioxide is more, automatically dissolving of the oxygen in the hemoglobin is less. That only the this one. Here, the rise in the partial pressure of carbon dioxide decreases the affinity of the hemoglobin for the oxygen. Next, if it is fall, PCO2 is fall, increase the affinity of hemoglobin for oxygen. See, one is increased, automatically one is decreased. That only. See, a rise in the PCO2 decrease the affinity of the hemoglobin in oxygen. Fall is there, automatically increase the affinity of the hemoglobin in oxygen. Here, simple one. This one is the two words you PCO2 and affinity of the hemoglobin. The oxygen PCO2 is right, affinity is will be affinity of the hemoglobin for oxygen is the decreasing. The PCO2 is fall, automatically the affinity of hemoglobin will be raised. Yeah. Second, next one is this one is also important. See this one. The what happened to the respiratory process in the man going up to the hills. They go to the up to the hills. What will happen? Actually, oxygen ratio will be decreased. Why means the see this one as altitude increases the PO2 in the atmosphere is decreased. Here the altitude increases the automatically higher means altitude is increased, the PCO2 in the atmosphere will be decreased. They are going to the up. What will happen means oxygen is decreasing. Here next when a man goes up the hills, he gets less oxygen with every breath. Here next the rate of the respiration increases in response to the decreasing of the oxygen in the blood. Here rate of respiration, oxygen is not available. That's why respiration rate will be increased. Here body is not getting the more oxygen, automatically the respiration rate will be increased. Here the simultaneously the rate of the heartbeat also increase, the increased supplying of the oxygen to the blood. Here what will happen means in the go to the hills means that places the oxygen is less. That's why the respiratory rate is more. Our cells are not getting oxygen sufficiently. Automatically the respiratory rate is increased. Respiratory rate is increased, simultaneously the heart rate is also increased. Here this one is about the what happened with the climbing in the climbing the man to the hills, the respiratory process, what will happen we discussed. Next one is the vital capacity we discussed. Next, now it is the tidal volume. Here, next is the the vital capacity is equal to tidal volume into expiratory reserve volume and inspiratory reserve volume we discussed. Here, what is the tidal volume? Now, this is this one. Here, tidal volume. Here, what it is? BC is equal to TB, tidal volume, plus expiratory reserve volume, plus the inspiratory reserve volume. Here, this we write for the vital capacity. Here, now we are, what is the tidal volume? Here, find out the tidal volume in a healthy man in an hour. In an hour, how much tidal volume is there? Count it, replace it. Next, it is the volume of inspired or expired air during the not forced. During the normal expiration or inspiration, that time our lungs are taking the how much air, that is called as a tidal. It is the volume of air inspired or expired during the normal inspiration or the expiration is called as a tidal volume. It is one breath. The how much means the 500 ml, and the per 1 minute means 500 into the 60. Here means the 500 ml 60. Here means the per minute about 6,000 to 8,000. Here the 3,000 means the 500 times means it is having the 6,000 to 800. The per hour, it is a per minute, sorry, per minute, how much it is there means the for one breath, the 500 ml. Per 1 minute, it is the 6,000 to 8,000. Per hour means this into 60, 6,000 into 60. 36, 3 lakh 60,000 or the 4 lakhs 80,000 is there. Here per hour they are asking now, that's why here this is about the tidal volume. Here the how much volume of the air we can normally, how much volume of the air we can take into the lungs or we can expire from the lungs is called as a tidal volume. It is about the 500 ml. The per minute about the 6,000 to 8,000. Per hour, it is the 3 lakh 60,000 or the 4 lakhs 80,000 ml is there. Clear? Next is a concave. Next one is, next question, next VSAQ is concave. Here, what are concave? Means the terminals in the nasopharynx. Here, see this one, respiratory part is there. The concave or terminals. These are the 3 spirally twisted bones. These are the small twisted bones in the respiratory part of the nasal chamber. Nasal chamber, inside of the nasal chamber, they are turbinals are there, are also called as spirally twisted bony plates are there. These bony plates are called as a turbinals, are also called as what the turbines are doing. Turbines are every time they are cooling the air. Here like that only. The concave are also called the turbinals. They are the respiratory parts of the nasal chamber. What it is means they regulate the temperature of inhaled air. For example, the summer season outer air is the warm. Means heat that is converted into normal temperature, they can give inside, they can transport inside. Next, like that in the winter season, the less temperature is there, that also converted into warm, means the warmth, and they can give to the inside. Here that is called as a concave. Concave means the spirally coiled bones, twisted bones present where in the nasal chamber. Here they are also called as the turbinals. Concave are also called as turbinals. What is the use of that means? They are regulating the temperature of the inhaled air. Here, this one is about the concave. Nasal chamber, they are present in nasal chamber, spirally twisted bones. The function is temperature is maintained, regulate the temperature. Next one is the chloride shift. In the carbon dioxide transportation time, the SAQs CO2 transportation that time I taken this one. That time also I said this one is important for VSAQ. Chloride shift. What will happen means through the carbon dioxide is transported in three ways. They are transported. Last one is by bicarbonates. Here in the bicarbonates time, what will happen means the HCO3 is enter inside of the RBC. The inside comes out from the plasma, RBC to plasma. Instead of that, Cl minus ions are enter inside. Here it is the plasma is there. Plasma. Here it is a blood vessel. Here what will which one is there? The means HCO3 is present inside of the blood. They are enter inside of the plasma automatically for compensation purpose. They are the Cl minus is enter inside. Thus shifting the exchanging of the HCO3 and Cl minus ions between plasma and RBC is called as a chloride shift. Simply the exchange of HCO3, Cl minus ions between plasma and the blood. Plasma and the blood is called as the chloride shift. Simply the exchange of HCO3, Cl minus ions between the plasma and the blood is called as a chloride shift. To see this one, that only. The exchange of chloride and the bicarbonate ions between the RBC and plasma at the tissues. Between the RBC and plasma at the tissues is called as a chloride shift. That is also called as a Hamburger's phenomenon. Here, simply exchange the chloride ions and the bicarbonates ions for the osmotic pressure maintaining purpose. They are exchanging, that we call as a chloride shift. Here, next one is mention the two occupational disorders, respiratory disorders. So in the SAQ we discussed respiratory disorders. Normal disorders are the one more time asthma, emphysema, bronchitis, pneumonia. Normal diseases these are. Some diseases are caused by the occupation. Means some people are working in the quarries and mines industries. Quarry and mine industries. That time what will happen means they exposed to the certain particles means dust. That time they can cause with the disorders, respiratory disorders that we call as a occupational disorders. Here what the question means, mention any two occupational respiratory disorders and their causes of the human being. Here the first what he gave the means occupational disorders are asbestosis, the black lung disease. The next one is the siderosis, silicosis. Here four are there: asbestosis, silicosis, siderosis, and black lung. Any two you can write it. Here they gave the asbestosis means exposure to the asbestos particles in the asbestosis industries. That is causes the asbestosis. Here exposure of asbestos particles cause the asbestosis. Next is the second one is the black lung disease. Coal mines. The workers, the people, those are working in the coal mines, they are getting the black lung disease. Here, those are, and other diseases are silicosis and the siderosis. Here, they are exposing to the, means the silica dust. They are causing they affected the silicosis. Those are the exposing to the iron particles. They are causing the siderosis. Here, this one is about the the occupational disorders. Now, this is the respiratory system, VSAQs. One more graph is also there. We will discuss this graph. See, the oxygen dissociation curve. Here, the partial pressure, carbon dioxide temperature and the pH, how they are affecting the saturation of the oxygen, that is shown in the diagrammatic picture, that is called as the oxygen dissociation curve. In this, what will happen? Observe here, in the x-axis, they are taken the PO2, partial pressure of oxygen. In the y-axis, the hemoglobin saturation. Here, for example, see this one, 40. You observe here the partial pressure of oxygen is 40. What will happen means they are the maximum. Here it is the saturation is the maximum. If the 80 above means 85 like that, the saturation will be there. Here next the 50 they are say that they are becomes as a down, and the 60 they are become, means what will happen means maximum saturation of the hemoglobin is when it is means the 40 mmHg. 40 mmHg O2 is there. That time hemoglobin saturation is more. The less than that one it is decreased. The more than that one also decreased. Mainly the saturation of oxygen is the depending upon the pH and the partial pressure of carbon dioxide PCO2 and also temperature. These three are affected. For example, see this one. The temperature is less. The carbon dioxide is also less. That time what will happen means the saturation will be increased. That will be that means the carbon dioxide and temperature is more. The saturation will be decreased. Here, see this is about the relation between the PO2, partial pressure of oxygen, and the saturation of the hemoglobin is shown like this. 40 mmHg time, the maximum saturation is occur. It is formed as a sigmoid curve. After that, the less are more. That is the less. See this one here. It is a 7.27. Like this here. This one is about the oxygen hemoglobin dissociation curve. With this, we finish the first unit VSAQs. The first one A, digestive system, VSAQs we discuss. Important only we are going to discussing. This one is about the respiratory system, VSAQs. Next. Next in this, not much the VSAQs are there, just sometimes they will ask this one also. That's why just I am only important only I am taking in the second lesson. See this one. In the LAQs already we discussed this one. What it is means the name of the valves got the left and right atrioventricular aperture of man. Here the first only we discuss in the structure of heart, we discuss about this one, and the heart is the atrioventricular apertures are there. Here this one is the right side, one aperture is there, left side one aperture is there. Right side aperture is guarded by the tricuspid valve. Here tricuspid valve. Left side it is guarded by the dicuspid valve, or also called as a mitral valve. Here means the valves, which valves are guarded by these apertures means this one. The left atrioventricular aperture guarded by the bicuspid. This one is the left atria, the left ventricle. This one is the right atria and the right ventricle. Between them, apertures are there. These apertures, right side is guarded by the tricuspid valve. Three cusps are there. Left side is guarded by the dicuspid valve. This is having the two cusps are there. That's why we call it the tricuspid and dicuspid valves are guarded this one here. Next, the right atrioventricular aperture is guarded by the tricuspid valve. Only the two names. Right is tricuspid, left is bicuspid valves. Bicuspid valve are also called the mitral valve. Here. Next is the in this lesson, not much. Sometimes you'll ask or not. I do. Only Thebaceous valve of the Thebaceous in the heart. That is also see this one. What is the valve? What are the valve of Tebezius in the heart of the man? Here, Tebezius valve, where they are present means the coronary sinus into the right atrium. Coronary sinus opens into the right atrium. That place, this valve is present. Which one? Tebezius valve is present. Here. Next one is the excretory system. In the excretory system, VSAQs are there. They are also important VSAQs. See this one. Next is the excretory system. Excretory system. VSAQs. Excretory system. Excretory system. VSAQs. Here, the what are the what VSAQs are important for that means all the columns of Bertini. The kidneys are there. See, I draw the draft diagram. The kidney. Here the medullary pyramids are there. In the medulla region, medullary pyramids are there. Between the pyramids, between the two pyramids, the cortex is enter inside this place. This is called as a columns of Bertini. Column like they are formed that we call as renal columns. Renal columns between the two papillae, the places are there, some gaps are there. In that gap, cortex is pushed inside. That we call as a renal cortex. Renal columns are also called as a columns of Bertini. Columns of Bertini. See, observe here. In the human kidney, the projections. In the human kidney, the projections of the cortex into the medulla, projection of the cortex into the medulla separates the renal pyramids is called as a columns of Bertini. Simply between the two renal pyramids, the cortex is pushed inside of the medulla. That we call as a columns of Bertini. This is a very, very important. You see, so many times gave the simple one also. The projections in the human kidney, the projections of the cortex between the renal pyramid is called as a columns of Bertini. Next is the distinguish between the cortical and juxtamedullary nephron. While the excretory system explaining time, I explained this one also. And here, what about the two types of nephrons are there? See this one. What it is? The two types of nephrons are there. Structurally, here it is the cortical nephrons. Cortical nephrons. First one is the cortical nephrons. They are present in the cortex region only. They are having the small Henle's loop. Henle's loop is a small, that is slight part only enter inside of the medulla. Most of the nephrons belongs to cortical nephrons only. Next, second type of nephrons is called as a juxtaglomerular nephrons. Juxtamedullary, not a juxtamedullary nephrons. These nephrons are having the well-developed vasa recta is there, well-developed Henle's loop is there. Here, the cortical nephrons, for example, this one is a nephron. Cortical nephrons are having they are having the small Henle's loop is present. But in the juxtaglomerular nephron is having here what it is, they are having the large Henle's loop, and that Henle's loop is enter inside of the medulla, and also that is surrounded by the blood vessels that is called as the vasa recta. Inside of the juxtamedullary nephrons, Henle's loop is large, and also vasa recta is well developed. See, I'll observe here. Nephrons cortical nephrons have the renal capsule in the superficial of the renal cortex. They have the short loop of Henle without vasa recta, means poorly developed vasa recta, or without vasa recta they are present. What about the juxtamedullary? Juxtamedullary nephrons are located near the renal medulla. Near the renal medulla, they are located. They have the long Henle's loop with vasa recta. I already said here this one is a cortical nephrons. These cortical nephrons are having the Henle's loop, but it is a short. It is not. It is poorly developed vasa recta. Surrounding of that blood vessels are poorly developed, or sometimes it is reduced. Clear? Next, in the juxtamedular nephrons, what will happen means the Henle's loop is prolonged, means projected inside of the medulla, and the vasa recta is well developed in the juxtamedullary nephrons. That's the two types: cortical nephrons and the juxtamedullary nephrons. Clear? Next one, nephrons are mainly two types are there. They are called as a cortical, in the cortex, in the name only there. Cortical nephrons means they are present in the cortex region. The Henle's loop is short. The vasa recta is poorly developed or is almost reduced. Here, next the juxtamedullary. Inside of that medullary name is there. It is present in the medulla region. Henle's loop is large, and the vasa recta is also well developed. Here, this one is about the cortical and juxtamedullary nephrons. Glomerular apparatus. JGA apparatus. Clear? Glomerular apparatus. What it is means? Juxtaglomerular JGA apparatus. JG apparatus. What it is means the here the macula densa with the juxtaglomerular cells together called as a macula densa means where they are the DCT means nephron is having the PCT, Henle's loop and DCT. In the DCT and macula densa, the means the both of them are where they are get together. That we call as a juxtaglomerular apparatus. It regulates the kidney function. Here, the AJ apparatus is where it is present. It is present with the macula densa with juxtaglomerular cells together form it as a juxtaglomerular apparatus. What it is means? It is mainly regulating of the kidney. Next, the most important one, the renin and renin. Two are there. RENNIN means the milk protein, the milk digestive enzyme that is here. Don't confuse with this. RENNIN. Renin means that is mainly helpful for the digestion of the milk proteins. But here, this one is the RENIN. RENIN. This renin, the difference is this one, renin and the renin. Two are there. This see, renin is produced in the kidneys. This renin is produced in the kidneys, whereas renin is produced in the stomach. In the stomach, RENNI, milk protein, milk digestion protein enzyme is produced. Here, renin converts the angiotensinosine into angiotensin 1. What is the function of renin? I'm writing here, see. What is the function of RENIN? RENIN. It is useful for the kidney function. Here, renin is the produced in the kidney. What is the use means angiotensinosine. It is present in the liver. Angiotensinosine into angiotensin 1. Angiotensin 1. Here, what is the use of RENIN means RENNIN. Renin is produced in the stomach. That is useful for the milk protein, casein protein into the digested into peptones. Here, renin converts whereas renin converts the casein into calcium paracasinate. Here, the casein in the presence of RENNIN converted into the presence of calcium ions, calcium paracasinate. casein. Here, this one is about the difference between the renin and renin. Very, very important. Note down this one here. Next. Next, last one more I take in the muscle first one, that is the triad system. This is also most important one. With this, I finish the class. See this one. First triad system means the each antitubule flanked the either side of the several cisternae, that is called as a sarcoplasmic reticulum. Here, the T tubule is there. That T tubule is flanked either side of the cisternae. That is having the both the sides. The cisternae of the sarcoplasmic reticulum is present. T tubule, for example, in the skeletal muscle, what will happen means the T tubule is enter like this. The T tubule between the two sides, the cisternae is there. Here, that cisternae is formed by the endoplasmic reticulum. T tubule plus two cisternae. That's why we call it a three. Tri means three are adding. One T tubule, two cisternae. That's why we call it a triad system. Here, each T tubule is flanked on either side by the several cisternae of the sarcoplasmic reticulum. T tubule and two terminal cisternae, its side is called as a triad system. Here, this one is about three are combined and form it as a system. Each one T tubule and the two terminal cisternae combined and form it as a system. This one is also very, very important, mostly given question. Here, with this, the remaining BSAQs we will discuss in the next class. Now, important only we are discussing in the last lesson, the two SAQs, ECG and ELISA is there. I will take in the next classes. Here, okay. Tomorrow same time we will continue.